Hello, geometry, and welcome to lesson 1-6 in topic 1, covering deductive reasoning. Now, we talked about in deductive reasoning the other lesson. Today, we're going to talk about deductive reasoning. Now, deductive reasoning to me is the reasoning that we're going to use a lot because, as you'll see, deductive reasoning uses all of your resources to draw conclusions versus patterns. So you'll see what I mean as we go through today's lesson. All right, so example 1, determine whether a statement is true. Given that a conditional and its conclusion are true, can you use deductive reasoning to determine whether a hypothesis is true? Oof. Sorry, that was a mouthful. So deductive reasoning is a process of reasoning using given and previously known facts to reach a logical conclusion. So deductive reasoning, again, uses given information and previously known facts, right? So it's not here's a bunch of examples, find the pattern. It's okay, this is what you're going to be given, this is what you know, make a conclusion. So for instance, right, we're going to just use a truth table to do this. So here's your common truth table, P, Q, if P, then Q. So if you remember from last lesson, we would start with true, true, false, false, and true, false, true, false. And again, this is just making sure we have all four combinations of true and false between your two statements. And again, the only one that was going to lead to a false was this one right here. If true, then false, make your conditional false. All the other ones are true, true, true. So the question is, given that a conditional and its conclusion are true. So we know that the conditional and the conclusion are true. Can we determine if the hypothesis is true? Well, let's find the rows where the conditional and the conclusion are true. So here's a true conditional and a true conclusion. Here's a true conditional and a true conclusion. But if you look here, look at the two truth values for the hypothesis. One is true, one is false. This is inconclusive, right? We, based off this information, cannot tell if the hypothesis is going to be true or not, because in one instance it's true, and in one instance it is false. So the answer is going to be no. We're going to say rows 1 and 3 show that the hypothesis hypothesis. I always put like two lines for the P. Hypothesis. Could be true or false. Could be true or false. And there you go. And that's all based off of building the truth table. And here is using given information to kind of lead to a logical conclusion. And again, we use the truth table, which is our previously known fact. Okay. All right. Next, let's see what we got to do. Okay, so we have this law of detachment idea, which is a great tool to use to make logical conclusions. So here's what the law of detachment says, right? So the law of detachment is a law of logic that states that if your conditional and your hypothesis are true, so if the conditional and the hypothesis are true, then your conclusion is going to be true. So this is different than the last problem, right? Where we knew the conditional and the conclusion were true, and we're asking about the hypothesis. Now we know that the conditional is true and the hypothesis are true. That's going to then lead to a true conclusion. And again, this law we're going to use often. Okay, right here. All right. So let's take a look at an example. Okay, so it says, example 2, apply the law of detachment. Assume that the set of given information is true. Okay, so it says, if Alicia scores 85 or greater on her test, she will earn an A as her final grade. Alicia scores an 89 on her test. what can you logically conclude? So this first statement is the if then, right? There is no then, but there should be then. So this is the conclusion. We're going to assume that it's true. So we're going to assume that yes, she can score an 85 or greater on her test, and yes, she can earn an A for her final grade. So this conditional is true, right? The hypothesis is the idea of getting 85 or greater. The conclusion is getting an A in her final grade. And then we have this second statement right here. This second statement is the hypothesis true. She scored an 89. So we know that P is true because she got an 89, which is greater than an 85. So therefore, Q is also going to be true. And the conclusion was the fact that she's going to get a final grade of an A. So that's what we're going to conclude. We're going to conclude that Alicia will earn an A as her final grade. And there we go. And that's all because we were given a conditional and a true hypothesis, which leads to a true conclusion. Okay, next, again, it says assume that the set of given information is true. If point D is in the interior of ABC, then the measure of angle ABC equals the measure of angle ABD plus the measure of angle DBC. What can you logically conclude about the measure of angle ABC? So this has this picture. So this is the if then, right? Let me use blue, if then. So D is in the interior. And if you look here, right, D is in the interior. So P is true based off this picture. Let me write this better. P is true. So therefore, Q is going to be true. So Q is the fact that the measure of angle ABC equals the measure of angle ABD plus the measure of angle DBC. So in the picture, right, we know that the measure of angle ABC is going to be equal to, well, ABD is 34 and DBC is 48. We know that the measure of angle ABC is going to be equal to 82 degrees. And that's what we can conclude. So this is very much what a proof, and if you've talked to any of your friends or older siblings and they mention proofs in geometry, this is what proofs really are about. It's about taking a picture, taking information, and making more conclusions. Great, so that's the law of detachment. We're going to learn the law of syllogism in the next video.